Welcome to the SmartKeys podcast. Imagine you are reviewing a massive supply chain routing plan for the next quarter.
Right, a huge undertaking.
Exactly. You feed all the constraints into your company's brand new multi-million-dollar artificial intelligence system, and it processes, millions of data points and outputs this highly optimized route.
Sounds perfect.
You'd think so, but there is a glaring issue. It routes your entire fleet right through a major predicted snowstorm.
Oh, wow. Yeah, that's bad.
Right. So you call up the data science team and ask, hey, why did it make this choice? And the lead data scientist just pauses, sighs, and says, we have absolutely no idea.
And that right there, I mean, that is the defining bottleneck of this current technological wave.
Yeah.
We have spent the last decade so completely obsessed with accuracy,
Yeah.
building models that are just incredibly good at recognizing patterns. But we neglected the human element. If a professional cannot follow the logic, they are not going to bet their career on machines' output.
They just won't do it.
Exactly. They will simply override the system, which means all that investment in artificial intelligence just, well, it sits on the shelf.
And today, we are cracking open the black box to solve exactly that. To figure out how to stop that shelfware scenario, we are using a really phenomenal source today. It is an 8-minute article by Felix Römer titled Explainable AI, Building Trust in Automated Business Decisions.
It's a great read.
It really is. Our mission in this deep dive is to decode how transparent artificial intelligence takes these opaque, unreadable mathematical models and, turns them into reliable tools that your team can actually trust and use out in the real world.
To set the baseline here, we really need to understand why these models became unreadable in the first place.
Right, like why are they black boxes at all?
Exactly. Because when you deal with complex machine learning, particularly deep neural networks, you aren't just writing rules like if A, then B. You are feeding the machine raw data, and it is building its own internal, highly abstract connections. So by the time it outputs a decision, that decision has been filtered through, millions of parameters.
Yeah.
Yeah. Even the engineers who built the architecture literally cannot trace the path of a single decision backward.
Okay, let's unpack this, because before we dive into the software that actually fixes this, Römer makes a very sharp distinction in the text between two concepts that get, frankly, constantly jumbled together in corporate presentations. And those are interpretability and explainability.
Yes, and they are completely different operational concepts. Interpretability is essentially a macro view.
Okay.
It means you can inspect the overall structure of a model and broadly predict how it's going to behave across a wide array of situations. You basically understand the boundaries of what it can and cannot do.
Right.
But explainability is a micro view. It is the ability to look at one specific individual output, like a single loan denial or a single medical diagnosis,
Yeah.
and explicitly state the exact reasons why the model made that specific choice at that specific moment.
I like to think about it like a high-end restaurant. Interpretability is like, well, it's like knowing that a highly decorated chef consistently cooks spectacular Italian food.
Right.
Because you know their background, their training, their past menus. You can reliably predict the food they serve you tonight will be excellent. You trust the chef's overall behavior.
Exactly.
But explainability, that is having the precise recipe, the step-by-step cooking instructions, and the exact gram measurements for the specific plate of pasta sitting right in front of you.
What's fascinating here is how perfectly that translates to the organizational chart.
How so?
Well, interpretability belongs to the data scientists. We need to understand the chef's overall style to, tune the model and ensure it isn't hallucinating wildly.
Right, making sure the system isn't fundamentally broken.
Exactly.
Yeah.
But explainability is entirely for the end user. The loan officer, the clinician, the supply chain manager. They need the recipe. They need to prove to the customer or the regulator or their boss exactly what went into the decision.
Makes total sense.
And having that recipe directly impacts 3 foundational pillars of modern business operations.
Those pillars being the framework for actually keeping a company out of trouble, I imagine.
Without question. The first pillar is auditability. Whenever a decision is made, you must have a breadcrumb trail linking that decision back to specific data inputs.
Right.
The second is governance. Your internal risk management teams, they require clear documentation to prove you are operating safely and ethically.
Okay, and the third?
The third is adoption, which actually brings us right back to your opening scenario. A user staring at a snowstorm on a map will only accept the system's strange routing choice If the system can explain, for instance, that it factored in a state-level snowplow initiative that cleared that specific highway just an hour ago.
Here's where it gets really interesting because understanding that we need explanations is kind of the easy part. The real challenge is the mechanics.
Oh, absolutely.
How do you actually get an explanation out of a system that was not designed to give one? The text outlines this Explainable AI toolkit, or XAI. So let's transition into the how. The first bucket of methods involves what they call feature-based attributions.
Right. So this is basically a way of quantifying credit. In machine learning, a feature is a variable.
Okay.
So if you were predicting housing prices, features would be square footage, zip code, age of the roof, things like that.
Yeah.
Feature attribution methods calculate exactly how much proportional influence each of those variables had on the final output.
Okay. And the article highlights a specific mathematical approach here called Shapley value, and its variation, sampled Shapley.
Yes.
Shapley values originally come from game theory, don't they? It's a method for distributing the payout of a game among players based on their individual contributions.
That is the exact origin. Lloyd Shapley actually won a Nobel Prize for it. To visualize how it applies to AI, imagine a group of friends going out to a very expensive, complex dinner where everyone shares different appetizers, main courses, and drinks.
Okay, I've been at those dinners. It gets messy.
It really does. At the end of the night, the waiter hands them this massive bill. Now, a traditional black box AI just drops the total number on the table.
No breakdown.
Right. But a Shapley value calculation acts like a forensic accountant.
Yeah.
It looks at the final bill and calculates exactly how much each person's specific choices drove the total cost.
But how does it actually know? I mean, if the model is just this giant web of connections, how does the Shapley calculation isolate just one single variable?
By running permutations. The system essentially recalculates the prediction over and over again, leaving out one friend or variable at a time and seeing how the outcome changes.
Oh, that's clever.
By observing the difference in the output when a specific feature is missing versus when it is present across all possible combinations, it isolates the exact percentage of influence.
Wow.
So it might tell you, hey, the zip code drove 60% of this high price prediction, the square footage drove 30%, and the age of the roof only drove 10%.
That immediately changes the dynamic for the end user. They aren't just blindly trusting a number, they're evaluating a weighted list.
Exactly.
But the text also brings up something called example-based reasoning, which relies on nearest neighbor retrievals. How does pulling past examples help explain a current decision?
Well, think about it. Humans naturally reason by analogy.
It's true.
If you ask a seasoned professional why they made a judgment call, they will rarely give you a mathematical breakdown of their brain. They will usually just say, because I saw a situation almost exactly like this 3 years ago, and here is how it played out.
Right. Experience.
Exactly.
Hmm.
Nearest neighbor algorithms do exactly that for the machine.
So it operates almost like case law in a legal setting. A judge makes a ruling today by citing 3 similar cases from the past. And the AI is doing the same thing. It says, I am flagging this transaction as fraudulent because it mathematically resembles these 5 specific historical transactions that were confirmed as fraud.
And that is incredibly powerful for spotting dangerous anomalies. Let's say the AI makes a bizarre prediction and you ask it for its nearest neighbors.
Okay.
If the historical examples it retrieves look absolutely nothing like your current situation, the human operator immediately knows the machine is confused. It has mapped your current data point into the wrong cluster in its internal geometry.
Right. So we have feature attributions dividing up the credit, and we have example-based reasoning citing precedent. But what if we want to interrogate the model structure directly? The article draws a line between model-agnostic and model-specific tools.
Yeah, this gets to the heart of how deep we really want to probe. A model-agnostic tool can wrap around any black box without needing to understand its internal architecture.
Any model at all.
Any model. The prime example the author gives is a tool called Lime. Lime builds a local, highly simplified surrogate model around just one specific prediction.
Wait, let me make sure I'm following the mechanism here. If Lime doesn't look inside the black box, how is it building an explanation? Is it essentially interrogating the model from the outside?
Interrogation is the perfect word for it. Lime basically plays a game of rapid-fire what-if. It takes your specific data point, perturbs it slightly, so it tweaks the numbers up and down a tiny bit, and feeds thousands of those tweaked variations into the black box to see how the black box reacts.
Okay.
And based on those reactions, Lime builds a simple, readable, linear map of that specific local area. It essentially creates a fake, easily understandable model that mimics the complex model's behavior just for that one specific decision.
That is incredibly clever. It maps the immediate territory without needing to map the entire globe.
Exactly.
But what about the model-specific tools? Why would we even need them if Lime can just interrogate from the outside like that?
Because sometimes, especially with massive deep neural networks processing, say, images or language, outside interrogation just isn't precise enough or computationally efficient enough.
I see.
That is where model-specific tools like deep lift or integrated gradients come in. These are surgical instruments. They actually crack open the neural network and trace the activation of the artificial neurons backward.
Oh, wow.
Yeah, they follow the math from the final output layer backward through all the hidden layers right to the original input data.
I have to pause you there because we have covered Shapley permutations, nearest neighbor vector retrievals, surrogate models through Lime, and backward tracing through integrated gradients.
It is a lot of math.
It's a ton. If I am an executive running a logistics company or a retail bank, my head is spinning right now. How on earth does an organization deploy all these advanced mathematical methods without requiring a PhD data scientist to sit next to every single employee?
And that is the friction point where most AI projects die in the prototype phase. The math is just too heavy for daily operations. But the current movement in the industry, which Römer points out in the text, is the shift toward managed governance software platforms. You don't build these explanations from scratch anymore. You buy a platform that automates them.
Right. And the article mentions Google Cloud's Vertex Explainable AI as kind of the flagship example of this trend.
It represents a massive shift in usability. A platform like Vertex essentially bundles all these complex mathematics behind a dashboard.
So the user doesn't see it.
Right. It takes the sampled Shapley calculations, the integrated gradients, and all those visual interpretation tools, and it bakes them directly into the pipeline. Whenever the model makes a prediction, the platform automatically runs the attribution math in the background and attaches the explanation right to the output.
So the end user doesn't see a wall of calculus.
Not at all. They see a clean interface that just says prediction X, primary drivers Y and Z.
So what does this all mean? We have established the mechanics. We know we can use platforms to automate the explanations. But why is this suddenly a board-level priority? Beyond just making employees feel comfortable, what is the ultimate business impact of investing in explainable AI right now?
If we connect this to the bigger picture, it comes down to navigating an increasingly aggressive regulatory environment.
Compliance.
Always compliance. The Wild West era of black box AI is closing rapidly. The article points specifically to the European Union's General Data Protection Regulation, the GDPR. It contains a clause requiring companies to provide meaningful information about the logic involved in automated processing that affects users.
Meaningful information about the logic involved.
Yeah.
I mean, that is not a suggestion. That is a legal mandate that effectively outlaws the use of pure black boxes for high-stakes decisions affecting European citizens.
And it creates immense legal liability. If an algorithm denies a user a service, and the user challenges it under GDPR, answering, well, our neural network decided it, that will result in catastrophic fines. And this isn't just a European issue either. In the United States, the California Consumer Privacy Act, the CCPA, requires businesses to disclose the specific pieces of personal information used and the inferences drawn from them.
You literally have to show your work.
You do. Explaining models lowers legal risk, absolutely, but it also drastically reduces operational downtime.
Because you aren't spending weeks trying to reverse engineer a mistake.
Precisely. When an AI inevitably outputs a wildly incorrect decision, an explainable system allows your engineering team to perform instant root cause analysis.
They can just look under the hood.
Right, they look at the attribution report, you'd see that the AI was heavily weighting, say, a corrupted data field, and they fixed the pipeline in an hour instead of taking the system offline for a month of blind troubleshooting.
Let's ground this theory in reality. The source material outlines a progression of specific industry use cases that show this technology moving from the individual level up to the systemic level. Let's start with the most personal one, healthcare.
Okay, so in modern healthcare, AI is heavily utilized in medical image analysis, reviewing X-rays, MRIs, and CT scans for anomalies.
Right.
Now, an opaque system just outputs a probability score, like 95% chance of malignancy. But with XAI, clinicians utilize visual tools called saliency maps.
And a saliency map is essentially a heat map overlaid on the original medical image, correct?
Yes, exactly. The system uses tools like XRAI to highlight the exact pixels, the specific shadowy regions of the image that triggered that high probability score.
Consider how transformative that is for the doctor-patient relationship. I mean, the clinician isn't forced to blindly trust the machine. They look at the highlighted region and validate it against their own decade of medical training.
Exactly.
If the AI highlighted a technical artifact on the film rather than an actual tumor, the doctor immediately dismisses the result. Furthermore, they can turn the screen around and actually show the heat map to the patient, bringing them into a shared decision-making process.
Transparency builds profound trust at the individual level. Now, moving up to the broader economic level, the second major use case is financial services. Banks are deploying machine learning for credit scoring and loan approvals at a massive scale right now.
And nothing generates more customer friction than an unexplained loan denial.
Exactly. But with feature attributions, the bank can provide a clear, standardized reason. They can say, your application was declined specifically because your debt-to-income ratio exceeded our threshold during these 3 specific months.
That transparency definitely speeds up dispute resolution.
It does, but internally, the stakes are even higher regarding anti-bias controls. Financial institutions operate under strict fair lending laws. They must prove their models are not proxying illegal demographic data.
Right.
So explainability platforms continuously audit the model to ensure it is only weighing legally permissible financial behaviors.
Which brings us to the most systemic use case mentioned in the text, and that is criminal justice. Courts and public agencies have increasingly experimented with automated risk assessment tools.
And this is where explainability is simply non-negotiable. Factually reporting on the text, the primary application of XAI in this sector is rigorous bias detection and oversight.
It has to be.
Because opaque risk assessments run the severe risk of encoding historical prejudices that are already present in their training data.
By demanding that these systems explain their reasoning, oversight committees can evaluate the exact features the algorithms are relying on. It forces the logic out into the open where it can be debated, audited, and corrected by human policymakers.
Yes.
I mean, it is really the only way to maintain any semblance of public confidence in the tools.
Whether you are diagnosing an illness, approving a mortgage, or evaluating public risk, the through line is incredibly clear. Explainability is the bridge between a machine's calculation and human accountability.
But knowing this and executing it are two different things. If you are listening to this right now, how do you actually operationalize this? You don't just buy a software package on a Tuesday and suddenly have perfect transparency on a Wednesday.
This raises an important question about what Römer terms life cycle governance. A major misconception is that explainability is a one-time audit you run right before you launch a model.
Right, like a final checklist.
Exactly. But in reality, a production-ready system requires continuous live monitoring.
Because models degrade over time. The environment they operate in changes.
That phenomenon is known as model drift. Imagine training an AI on consumer purchasing habits in 2019 and then letting it run unsupervised during the massive behavioral shifts of the 2020 pandemic.
The data would be completely irrelevant.
The underlying data distribution radically changed. If your model doesn't adapt, its accuracy silently collapses. So the practical playbook requires organizations to set up automated pipelines that track feature importance in real time.
So the system is constantly checking itself. If the variable that used to drive 60% of the decisions suddenly drops to driving 5%, the pipeline throws an alert.
Exactly. It surfaces those explanations to human operators immediately, signaling that the model needs to be retrained. And crucially, this automated reporting has to function smoothly across complex, multi-cloud, and hybrid computing environments.
That is a significant infrastructure build.
It is.
That sounds like an overwhelming mandate for an IT department. Rebuilding your entire data pipeline to support real-time mathematical permutations and heat maps.
Which is exactly why the author's final, and perhaps most vital, practical takeaway is this. Do not try to boil the ocean. Organizations fail when they try to retrofit explainability onto every single legacy model in their company simultaneously.
You have to start small to prove the value.
Pick one model, just one high-impact, visible model where human adoption has been sluggish. Turn the explanations on for that specific system. Embed those new, clear insights directly into the daily workflows of the team using it.
Yeah.
Let them experience what it feels like to interrogate the machine and get a logical answer back.
Convert the complex mathematics into a simple, everyday operational dialogue. Because once the team on the shop floor realizes the AI isn't some mysterious oracle, but just a highly capable analyst showing its work, the entire culture around technology in the building changes.
The skepticism melts right into active collaboration.
Visibility is the ultimate antidote to algorithmic anxiety.
Well said.
As we wrap up this deep dive, I want to leave you with a thought that builds on everything we have covered, but perhaps challenges the core premise a bit. We have spent this time establishing that perfect explainability, getting the exact recipe, breaking open the black box, builds trust and empowers human professionals.
Right.
But consider the long-term psychological effect. If artificial intelligence systems become so perfectly explainable that they consistently, flawlessly justify their reasoning to us with brilliant logic every single time, will we eventually stop questioning them altogether? If the machine's logic is always visibly perfect, does perfect explainability ironically run the risk of lulling us into a false sense of security, ultimately lowering our own independent critical thinking? Just something to mull over the next time an algorithm hands you a perfectly reasoned answer.
A fascinating tension to navigate as these tools become more and more integrated into our daily cognitive routines.
Thank you for tuning in to the SmartKeys podcast. We know your time is valuable, and we appreciate you spending it with us to map out the future of business efficiency.
It has been a pleasure to unpack the mechanics behind the shift.
If this strategy session gave you a new perspective on your technology stack, please subscribe to the podcast so you never miss an insight. And I highly encourage you to read Felix Römer's full article, Explainable AI, Building Trust in Automated Business Decisions. The text contains excellent visual frameworks of those saliency maps and deeper breakdowns of the life cycle governance architecture. You can find the direct link to the article right in our show notes. Until next time, keep demanding the recipe.